Hey guys, Wages World here. It is the 21st of June 2020. Today is Father's Day, and happy Father's Day to everybody out there. Anybody that's in that role, anybody that's stepping into that role to try to help, I applaud you. Take today and appreciate yourself and appreciate those that were your fathers also. So anyway, we'll move on. We're going to talk about the Schumann here real quick, but also we got the Ring of Fire to take a look at, the solar eclipse thing, and some CMEs and some other stuff we need to talk about. So anyway, I didn't do a video yesterday. Guys, I hurt my back pretty bad. I actually fell down a ditch, and I have been really struggling to even move. And I don't do pain pills because I'm fused 6 in my neck and 3 in my lower back. So, well, 2 in my lower back, sorry. And, you know, any kind of injury like that really messes with me. But anyway, I just wanted to give you an explanation on why you didn't see a video yesterday. So, you guys look at this right here. Most of this graph used to be blue. And now we're looking at about 50-50 to green to blue. And what that means is that our frequency's increased. It's picking up more frequency right here. And, you know, it's a good way to show you that this is our new norm, because there are no spikes here. Not any long-lasting ones. So we can't say it's coming from a spike. This is definitely our normal conditions right now. This is observational proof that our frequency has increased. And I'll point everybody over here and say the same thing all day long. But if you look over here, guys, the tool actually went down. See the black lines? Went down a couple times, very short-lived, but it came right back up. We haven't, the big black over here on the side, for those that don't know, that time just hasn't elapsed yet. There's no data there yet. So, our coded line is showing up right there. That's right around 16 hertz, okay? You can see where it was down here also at 24, but it stopped. Okay, and this is why, and then it started picking back up over here. I see one little dash. Now, look, that's why I don't think it's a tool fault, because it starts and stops. It doesn't always stay there. Plus, we're starting to see that line creep up towards our normal frequency of 7.83. What happens when that meets it? You know, I don't know, guys. It may nothing happen. I just don't know. So that's what I would say to that. But yeah, so we'll just keep an eye on this. We'll pay attention. Not a whole lot of spikes. Just a bunch of pulsing. You can see it. The white lines that are pulsing through there. It used to be solid blue, guys. Just saying. Okay, guys, I got you over here at spaceweather.com. They do a really good job. They did an article on this. Go check it out. It's, you know, they do good work over there, so go check them out. spaceweather.com. Now, this right here obviously is that eclipse. That's when it was just coming into view. And then this one right here when it was the full ring. Okay, that's just amazing to look at. It's crazy. Can you imagine being back on the 3rd or 4th century and looking up in the sky and seeing that? Not to mention that it almost went completely dark because of this. Imagine how freaked out you would be. And I think a lot of times that's where a lot of these prophetic writings come from, is stuff like this. And that's what I think, because you can tie it right back to about when those events happen. And it's definitely something we can't ignore. Now, we know what causes this today, but back then they didn't. So they could only interpret it the way that they knew. And that's how they did it back then. So anyway, why does that only do that? A lot of people are asking. Well, because it's not covering up the whole sun. And it has to do with the distance of the moon to the earth. Okay? If it's further away or closer to us, it'll cover up more or less of the sunlight. In other words, it's going to cast a bigger shadow or a smaller one, depending on the distance between us and the moon. So anyway, that's what I would say to that. I just thought this was really cool. Thought you guys might want to check it out. Also, guys, this is a every 500 to 600 year ordeal. Okay, so this is a once in a lifetime thing. We will never see this again in our lifetime. So that's pretty cool in itself. Okay, guys, also this is during that eclipse. And what you're seeing is, if you look here, you can see the moon go across that way. That's the shadow of the moon. Okay? Isn't that kind of crazy? You can see it zip across there. Now, I know this caught my eye. I'm sure everybody else is kind of seeing it too. I don't know what's causing that. I'm not going to say that it's anything to worry about because I just don't know. It looks like it's reflecting off of something there. Whether it's a mountain chain or something like that, I don't know. But there's definitely a reflection going on there. So whatever that is what it is. It could be, I guess it could be a reflection from the camera itself also. But you can follow that all the way through, and it even goes way over here. See that? And it probably has something to do with the angle of the sun and all that kind of thing. So I just wanted to show that to you. But I thought that was pretty cool, seeing the moon shadow go across there. Okay, guys. Got you back over here at Lasco C2. It is our view. Okay, Earth here, satellite there. We're looking that way. Now, what you're going to see here, guys, is there's a couple CMEs going on here. Again. Okay, first one's going to be here. You watch, see, there it goes. Okay, now we're wondering, did it go to the right? I understand that's what the question is going to be, but then we had a second one over here. Now, is any of this coming at us? I don't know yet. I've been trying to wait for the CME tracker to update, but I haven't seen anything on it yet. We'll go take a look at it again here in a minute, see if it has. But I think those were filament releases. There was a filament on the northern half of the sun up in this area, and it may have released off. I don't know. I went and looked at SDO, and you could see some filaments, but I didn't see the point of when this thing kind of blew off. So is it coming at us? I don't know. So what we're going to do is we're going to take a look at stereo A. Okay, now why I wanted to take you over to stereo A is because if we've seen, because this is a side view, the Earth is here and the satellite's here that we're looking at right now. So if we've seen it looking like it was going off this way, that would mean that it would be going off the backside of the sun, away from us. Okay, but it's not. It's actually, I'm going to push play here and you're going to see. You start that back up. Okay, so it looks like it's going to the right on this one. Now, it's still not definite that it's coming at us, because what I want to say is when we're looking from the side here, if it's going to the right, like what it's showing, it could actually be going this way too. Okay, or even this way, but going off of what I just showed you on Lasco C2, this is kind of out of the question. Except for that second CME that blew off. That could be coming this direction. But I think that second one, I'm not really sure, but it looks like it may have went kind of this direction. But we're going to have to wait and see. we're going to go check out the CME tracker. But I'm going to show you this too, okay? Pause it. I'm going to back it up. Okay, you see this? Now, again, typically I wouldn't even talk about this, but that is such a strange shape, okay? We don't usually typically see them that shape. Sometimes we'll see, anomalies or whatever that are very, very cylinder looking, but this one tapers down, okay? It's kind of tapering down like that. Now you're asking yourself, where have we seen that before? Well, let's go to the previous day. And we're not going to see nothing here. Okay. Let's go back 2 days. See that flash? So see if we can't stop it on there. Okay, I'll back it up now. Okay. You guys see that? Is it me, Or did it look like it was here, and now 2 days later, it's over here? That looks like the same exact signature, guys. Okay, so let's go back to the one I showed you from today. Right about, come on, there it is. Okay, does that not look like the same thing? So if that is the same object or whatever's causing that, it took it 2 days to move from here to here. And you know, we've been seeing a lot of flashing going on the sun, at least on the tool. You know, I'm not saying the sun's flashing. What I'm saying is we're seeing some of those signatures. So now we got the same exact looking anomaly that has moved, and it took it 2 days to move that far. Okay, it was right here, and now it's over here. So you guys take for whatever you want out of that. I don't know what to think about this, just to be honest. It's like, because if you look at this, guys, I can't believe I'm saying this, but see how it's brighter here than it is here? If that light was coming from the sun, like it was reflecting the sunlight, the brightness would be over here, not here. So I don't know what's going on, just to be honest. And that could be a camera anomaly too. I don't know. All I'm saying is that it's really odd that we've seen both of those signatures looking almost exactly the same on the same tool 2 days apart. And in my mind, moving from here to here in 2 days isn't really out of the question. Okay. So that's kind of what I'm saying. Now, to the CMEs that were happening, you can see that energy going here off to the right, and like I said, I already showed that to you. But you know, so what we're going to do, we're going to go over and look at the CME tracker. Okay, guys, this is PlanetXnews. Scott's website, and this is how I go to get to my links. A lot of them. I haven't shown you guys this in a while. So if you guys go over here, all you do is click on the 3 bars on the left. Then it says PlanetX Research Links. Okay, you click on that. You can X out of that advertisement, and then you go down here, and here's all the links. You see them here? There's more, but we're going to go to the CME tracker. Okay, we're seeing all the ones I've shown you today. You can get to from here, and I would go over and read these articles too, because they're great articles he writes. So a lot of good information in there, guys. Please go check them out. I mean, you'll learn a lot doing that. So CME tracker, you just click on the link, takes you right to it. Okay, now what I'm seeing here is this is updated now. Okay, it's showing you, I believe, the small one. Yeah, that's exactly what it's showing you right here. That was the second one. Okay, it's going right at stereo A. It's going to hit stereo A. That's what it looks like anyway. But we don't see the first one on there. And that happens often because it could have already shown us the first one. But when this thing sees another one, it goes to that one and shows you data just for that one. That's how this thing works. It's crazy how it works like that. But that is the case. And so we don't get to go back and look at his historic archive data on this one either. So it does kind of suck. But you can see that, you know, that would be today. And then, you know, you can follow it down as far as the days go if you wanted to. But here's stereo A over here. And you see how, do you see that little haze that happened around it? Watch. Right there. Do you see that little blip looking thing? Right on the end of it, watch. Right about there. See how it kind of hazed over a little bit? And that's a very small solar storm or small CME, whatever you want to call it. That ain't going to do hardly anything to anything, just so you guys know. But it did happen. So that's just another indication of the sun starting to wake back up. So at this point, I don't think that CME is coming at us. So, you know, I think we're kind of in the clear on that one. I'm not seeing anything hitting Earth over here at all. Maybe some higher dense solar wind or something, but that's about it. All right, guys, I got you over to Geoelectric field model. This is basically space weather effects on our electrical grid. It's giving you that kind of a chart or a look at this. And again, this tool is only about a year old, so we're all still trying to learn it as best we can. You know, I learn stuff on it pretty much every time I look at it. But what I can tell you is that darker blue you see would be what would be normal. And the little blue stuff we're seeing flashing isn't really that big of a deal, but watch this. See that? What'd that look like? Look like a big, you know, if we were looking up at, if it was local, it would look like a lightning strike. You know what I mean? Like a lightning flash in the sky. But what that is we got a burst of solar energy probably that came this way. And that's where it hit. It came in at. Okay? It's more of a precise thing when we're talking about this. But you can definitely see it. Because it gets into the green color. Let's see what we see here when it does it again. I wish I could put it, well, I guess I could record it and then slow it down, but I'm not going to do that. But anyway, you guys seen that flash. You can go up here and see when it was most intense. Let's watch this number for a minute, see how high it gets when it flashes. It'll probably get like 16, 17, I'm guessing. Maybe a little higher, we'll see. Oh, 16. Okay, anyway, yeah, so that was a decent little pulse right there. So is it going to cause anything to happen? Probably not. Usually when we see things happen like that, it tends to last a little bit longer. Now, like a solar flare, if it was the burst with a big solar flare and it made it here and it hit right there and it was a lot stronger, we would see immediate effects. So just so you know. Okay, guys, I got you over at Space Weather Prediction Center, NOAA. Okay, it's where we go to look at our space weather conditions. There's the electron flux. Basically, it tells us if we've been having flares or not. It doesn't look like anything's going on there. Everything's still real low. That's because that bigger sunspot or active area rotated off. It's not facing us anymore. So the electron flux went down. Just so that's how that works. Now the proton flux, I've talked about that. We don't even really look at that because it hardly ever changes. So, but this right here, geomagnetic activity. Again, this is where we look at for solar storms levels or geomagnetic activity storm, or yeah. So, in the KP index, if it goes up, a geomagnetic storm, this is where we go to see it, or at least see how big it got. I'm sorry about that. Kind of choking up there a little bit. Anyway, you see how we're right at 1 on all that? If that continues, they will issue a cosmic ray alert. Okay? We have to have some geomagnetic activity to fend off cosmic rays. And right now, it's pretty low. And if it lasts like that, that means cosmic rays get in easier. So that's what I would say to that. Now, the other day I was talking about the coronal hole situation, how it was real patchy and stuff. Well, this right here is a legitimate, decent sized coronal hole. That may open all the way up. We just don't know yet. Gotta wait. You can also see the southern part of that. A lot of times what you'll see is these two will like grow into each other and be one big hole. So if that happens, obviously we'd have a solar wind event, you know, within 3 to 4 days probably. But here's the equator, and here's the Earth. So that's rotating right through us, okay? So here in about 3, 4, maybe 5 days, we're going to see an increase in solar wind, and it may, you know, raise our geomagnetic activity level up. It'll probably most definitely give us auroras. It can do a whole lot of other different things. It'll, you know, give us a hit on our magnetosphere, our shields. We'll probably fend it off just fine. I'm just saying, that's what we'll see. So